I'm CK. A little while ago I did the VCF-Q, the variable resonance filter from random source based on the Serge design. Tonight we've got their other filter, or the other filter I could find, their VCF-S with the variable slope. So when the control is in the center, it acts just like a multipass filter, and turning it up changes the sloping for the filter, increases resonance, and can get a very sharp drop off. So we'll put it together, see how it sounds, and I hope you enjoy the video. Here are the bags, or containers, whatever you want to call them. Here's the panel on the PCB. Here's most of the stuff, and here are the real change between the original Serge design and what Random Source has done with it. These are these are high-end VCAs that are optimized very well just for audio. So we'll see how they sound. I got the B version. There's A, B, and C, and I always forget which one is which. So when I bought this from thonk.co.uk, I just grabbed this one. It's order number, it's got the order number and the amount 2. Okay, and let's start tearing into it. We'll look at the front panel and the circuit board first, as it's all enclosed in non-recyclable bubble wrap. And here's the front panel and the outputs: high pass, band pass, and low pass, in 1 and in 2. I didn't know they had 2 ins. That's interesting. Mix and VCF and VC, voltage controlled slope and voltage controlled frequency, and 1 volt per octave. Slope, Q, and freak. I don't know what those are. Are they pots? They're pots. Looking at the circuit board, those are pots, these are pots, these are jacks, pot, jack, 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 jack. Let's look at the board, and they did it again. So when people manufacture boards like this, the board house usually makes, if it's this kind of size, they'll make like 6 or 8 on a big sheet, and then you break them apart. But these guys left all the little nubs on. They need to take the nubs off. Yeah, see, they did one of these, one on this one too. Okay, there we go. Go away, little nub. Let's look at the main board. Whole bunch of resistors. 1, 2, 3, 4, 5 ICs. That's very similar to the VCF-Q, which you can see on my channel, and I'll put a link in the description if I remember which. It's 95% certain that I will not remember, and I will not do it, so you may have to search for it. So let's see. Again, this is the layout is very similar to the VCF-Q. Power, these could be ferrite beads, but in the last kit they were resettable fuses. Might be that too. A couple of decoupling caps, smoothing caps, and a bunch of resistors. This is another cap that they put on, and I'll have to look carefully at the instructions, because they occasionally do not. Yeah, see, the bill of materials and the notes tell you what to do. Oh, and it does have what it looks like, one surface mount part on the board. Where would that be? Oh, here it is, right here. That is the match transistor pair in a surface mount package. That's T2. That's right here. So we're going to be doing a little surface mount, just a little bit. And on the back, these pads you can, instead of using the 100 nano decoupling caps that they include, you could get 100 nano surface mount caps and put them back there if you so choose. Let's see what we have. So the main board resistors have been adjusted to allow a wider slope range than the original had. And the bill of materials below shows a fancy reference building feature featuring some slightly radical part choices compared to the vintage version. In particular, omitting various capacitors, original values are shown as well. That should work well as long as you use the high-end op-amp specified. So, and you can experiment with other op-amps, but you might have to add capacitors. So, on the other board, they were marked as CS and CY. We'll figure it out as we go along. But what I'm highlighting here as I ramble about this is you have to look at the bill of materials as well as the build guide itself, because he's got various notes in the parts list that often would be normally found in the build guide itself, but the build guide's relatively straightforward. Huh, what is this? What is he talking about here? He's got a picture here of something here. Solder the banana jacks in. He's got sustain release. I'm sorry, I'm noticing something on the picture in the build guide that I don't know if I see it here. I'm sticking my head in the shot. I don't care, because I don't know what he's pointing them out to me here, because I mean, he's got this little picture that shows banana jacks and shows sustain, release, and some other ones, but there is no, don't fall over. I'm trying to do a video here, little stand, stay up. But I don't see that on the board, so I don't know what he's talking about. Not on the front, not on the back. So I don't know what's going on. We'll figure it out. Okay. Now, we've looked at the circuit board. Let's see what the bits and pieces are. Bunch of little plastic bags. You know my feelings about bunches of little plastic bags. If everybody would look at what Division 6 does for supplying resistors, or even other company that Velleman on general purpose kits does it better than this. I'm sorting out all the resistors now because we're going to be doing those first. Of course, actually we're going to do the surface mount part first. And this is all the resistors and diodes. Oh, these, he does include ferrite beads this time, pre-assembled, not resettable fuses as he did on the last one. Here's all our caps. Here's matched pair of diodes. I mean diodes, transistors, for crying out loud. And do not confuse with the matched pair. I won't. Thank you for hollering at me. And it's got 3 TL072s, which are op amps, and 2 of the OPA 2134s. So why... I'm going to go take a look at the FATs. because the THATs go here. They're these long things that if you were to see them without knowing that these existed as little VCAs, and there's two here, okay. You might confuse them, as I did initially, with resistor packs. You know, you'll see an inline 6 or 8 resistors with one common lead that often are used for things like LED grids and so on, but they're not. These are op amps. These are amplifiers, VCAs. So we've got 5 op amps for general purpose use and then 2 THAT assemblies. Anything interesting in the mechanical bag? I don't know. Let's see. I'm going to dump the mechanical stuff in this bin for right now. Power connector, or power cable. Oops, almost missed a socket. Come on. Bunch of green base pots. Are they all the same? Probably so. Looks like they're all 100K. Oh, no, there's a 250 in there. So we got to be aware of that. The others are 100K. And the knobs are definitely plain vanilla. There's no set screws, there's no serrations, there's no flat spot. So it's very basic pots. And we've got a couple of female pin headers and one long male pin header strip to cut down to use with those pin headers, and a bunch of thonkified jacks, and one trimmer. I believe it's only one. Yeah, there's only one trimmer, and it goes right here. I assume it's to set the volts per octave input range correctly. So that, not talking about this, talking about that, is what's in the package. Looks like a pretty straightforward build. Again, there's one surface mount component, which I actually, as I just went through all this, I didn't see. So let me find it. Unless he's using this matched pair instead. There's a sticker under here. There's one sticker under here. So, right. So it looks like they may have, this says matched pair 2N3904. That may be the surface mount part. No? Huh. Now I gotta find that part. It's not in there. So this is the same. Okay, so they just changed, they added additional information on here. But again, I'm not finding the surface mount part. Okay, so the main PCB version 1.02 provides for a BCM847DS matched transistor pair and SMD. It's the only SMD it's recommended. So it provides for it, which is, okay, yeah, it looks like they're going, it's an either or. You either put this in or you use the 2 matched transistors. So if you don't find the surface mount part, don't worry about it. I've already worried about it for you. So let's get the soldering iron heated up and get this thing together. He actually starts the build guide by putting some stuff on this board, but I'm not going to do that. We'll do it in the way that's somewhat standard, which is the main board, and then put the stuff on the panel PCB and mount them all together and all that. Again, his build guide is not a step-by-step type build guide. It's kind of a little disorganized, for lack of a better term, and that's not really fair to him. It's written with the assumption that people have built electronics before, so we'll take that as intended and just put stuff on. And I'm going to start with the 2 ferrite beads. Now they look like diodes, but they're not. These are, I'm going to zoom the camera in a little bit. Again, I got a new lens, so I can zoom in and out more. Tell me if it bothers you. So instead of, this is just iron ferrite molded into a cylinder. Typically on most uses you'll get a loose ferrite bead and you use a resistor leg to solder them in, but these came pre-wired, and they are not polarity sensitive because they're just they're chokes, they're inductors, whatever you want to call them. They're just taking a little noise out of the input signal. I mean the input power. And I sometimes use them, sometimes I just put a jumper in because I use really clean power and I don't worry about that much, but since he provided them, I'll use them. Now we'll put all the 4148 Zehners on the board, and they are at D1, 2, and 3, and these are polarized. There's the black stripe that tells you which way to put them in because it'll match with a white line on the PCB, like right there. So that'll go in there. And the holes are much wider apart than they need to be, so I have to manipulate the wires a little bit because I bent them too close to the body of the diode because I thought the holes would be closer together. Next we're going to put a whole bunch of resistors on the board, which is not all that interesting, so we will go into fast playback with no commentary, and I'll probably cut out some, if not a lot, of the resistor placement. And while I'm doing that, I'll be listening on WQXR on their iPad app. That's classical music out of New York. Best classical station in the world in my experience. And we're going to start with Symphony No. 3 in C minor by Louis Spohr by the Radio Philharmonic in Germany. So enjoy resistor time. And that is resistor time for this kit. Not too bad. The only thing to note is there are three resistors on the pots and knobs board. So, and the build guide and at least the packaging from Thunk is very clear about that. So that's easy. Now I'm looking to see if he has any other suggestions. No, he doesn't. So what I'm going to do next is find the sockets and put the sockets on the board. We should have... You know, this is the oddest thing. This is the second time on the VCF-Q. The same thing happened. It's not a bad thing. just an interesting thing, and I'll tell you in a minute once I get... So we've got the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 sockets, and he gave us an extra 16 pinner. I don't know why. I don't know whether it was the folks at Random Source or the folks at Thonk who packed extra sockets in here. I mean, they go in the spare parts bin, socket bin, so they're not going to go to waste, but they do cost money. I mean, not a lot, but when you're pumping out kits, it can add up. So I'll do one leg and double check that it's all flat, and it is. And I'll do that for all of them, and as always, remembering to put the notch on the socket at the same orientation as the notch printing on the circuit board. And all the sockets are on. And that's what I'm going to be finishing with tonight, because the cats are starting to scratch at the door because they're hungry. So I'm going to go feed them. Now we're going to put the capacitors on, and this is where you got to look at the bill of materials, because like C5 and C6, as I mentioned earlier, where did my pointy thing go? C5 and C6, which are somewhere. Okay, here's C5 and C6, probably should be by one of the other caps, yeah. I mean ICs here. They're omitted in this design. They were in the original design, but they're not in this design. So we're not going to do those. So that's the 2 15 picofarads on the blue taped ones, and we're not going to use those. We could, again, the Random Source folks bring it up because it was part of the original design from Serge, and if you want to do that, if you want to go complete old school original design, you can, but they don't recommend it. I think what we'll do first is the 2 styrene caps, C7 and C8. That's these guys here. And they say they're matched. I don't know about that. I mean, I have no way to validate that, but I'm going to make the assumption that they're correct. And we've got 10 270. Oh, no, wait. I'm sorry. I'm getting ahead of myself. And now we have 1 270 picofarad cap. Gosh, I really hate this gray. I've always hated the gray on the gray on dark blue of these capacitors. I had to drop my other lens in my 271, so that's 27 and 10, so that's 270. That goes in C9, and it says omit it, so we're not going to do that. Again, it's listed here without saying omit, but the bill of materials in the build guide says omit it. Now we'll do all the 100 nanofarad decoupling caps, 10 of them. And they're all 104s. Yeah, that's 104. Okay, now the 470 nano, yep, 470 nano, oops, that's needle nose, not clippers. Film cap at C10. Throw this in the garbage. See, there it is, nice square outline on the board. Now we'll put the 2 electrolytics on, and there is a nice, easy to read plus sign for the long positive leg. And I think we'll put the transistors, let me dip that back in there. There's a jumper here that's not used. These are the pin headers that will connect the two boards. So first I'm going to put the, actually I'm sorry, I'm distracting myself. I'm going to do that chips also right at this point. Get them out. Now they have a certain orientation, of course. There's a highlighted square around one end, and that's where the notch end of the vat goes. And I'm going to put the transistors on also. If I can find them. What on earth did I... There they are. They're hiding. They're hiding. This goes in Q1 and Q3. I'll put my soldering iron down for a minute. So one is the emitter. And the emitter, the E emitter is marked with an E on the board. Why he didn't choose to just do the standard outline with the flat spot, I don't know. Again, if you're not sure, just look up the data sheet online for the transistor that you've got, and it'll show you which leg is the emitter, and just put that in the hole marked as E on this board. Now we put the power connector on, and it's got a notch because it's a keyed connector, and there's a notch on the board, but we do want to verify by putting power cable in just a little bit and making sure that the red stripe is going in the right place, and it is. Because just like with sockets, what it says on the circuit board is more important than what the connector might show. That's all flat. Yep. Now we'll do the pin headers, and they're all pre-cut. No, they're not pre-cut. The males are not pre-cut. The females are pre-cut. Actually, we've got the 6, and we've got a 4. There's these on the back like so. And again, I'm just going to roughly get them roughly aligned for a second, and then I'll fix them up in a little bit. I may as well put these on the pots and jacks board too while I'm here, while I'm in the pin header mood. Just grab this here. Sure I got the right number of pins. Actually, what I'm going to do is this. This is actually kind of fun. It's kind of a fun way to do it. I'll just shove it in there. Now we'll get this one. And shove that one in there. Clip it off. And shove that one in there. And put them together for the moment. Push down a little bit, so I've got a little, I'm taking up all the slack. 1, 2, that's 3. I'm going to take it back apart right now. Oops. Set this aside again, and I think I'm going to put all the ICs in. We've got 2 of the high precision audio op amps and 3 TL702s. So the circuit board listing, which is not actually the same as the board we have in our hand, quite frankly. This is interesting. Oh, now this is VO2, isn't it? Let me double check. I don't see the version number on the board. No, this is V1. Okay. Please refer to the previous version of this document for versions less than 02. Well, let me see if I was... Okay, so we've got the 2 OPA 2134s going IC1 and IC2. That's here and here. So let's see which ones those are. I believe they're this one and this one. Double checking. Yeah. Where's the dot and the notch? Oops, bent a pin. Fortunately, I bent a pin on a TL072, which I've got like 100 of in my spare parts cabinet. So even if I couldn't fix it, I'd be okay. So that is the main board. Now on the Rev 0 board, you can put, he doesn't omit the C5, C6, and the C9 cap. But I'm going to, because on the follow-up version he did, and the board layout is basically the same, not much difference, so I'm just going to leave that like that. Now we'll move on to the pots and jacks board, and let me see, the only thing I really care about is there's the one 250 pot, and that is the resonance. Oh, where'd it go? Oh, I did forget something. I knew I was forgetting something. It was because it was in the wrong bag. Here's the trim pot for voltage per octave, which, as he mentions, it doesn't really matter. You're not going to get much fine note tracking with this board, so kind of putting it on just for the heck of it. You could probably put a jumper in there and the board would work just fine. So, back to what I was saying. The 250 is for resonance, the Q factor. Where is it? There it is. And all the other four are 100 ohm. Actually, the other 5 are 100 ohm. I should probably do the rest of the pins on these. Now we'll set all the jacks in place. Now we'll take the front panel and put it on. And get my little clamp things together for bed. Make sure everything's tight. If it's not tight, I want to know why. Now I'm going to solder everything down. Now we'll put panel nuts on, and that will be exciting, so I will replay it in fast motion. Now we'll put the knobs on, so turn everything counterclockwise. And again, they're simple knobs, just press them on. There's no indexing. There's no notches you're lining up with on the shaft. And get them as close to matched with each other as you can. Hopefully you can match them better than I do. It's one thing I don't do very well. I'm sorry. It's one of the many things I don't do very well. This one I happen to do on camera. Or I give somebody a guitar amp back and all the knobs are slightly offset. Okay, that's that. And now I'm going to remate the boards. And we'll put the power connector in. Oh, I'll point something out in just a second. I did not put the spacers in because this is never going to move out of my studio and I don't worry about bumps and bounces loosening the boards. If you gig or take your rack on the road somehow with you, I recommend you put the spacers in just to make sure things don't wiggle out of place. I don't, because again, this is not going anywhere. But there's the front, that side, the back, that side, the top, and the bottom. Now let's put it in the rack and see how it sounds. Okay, it's in the rack. I've already turned the power on just because I forgot that I should have done that on camera. But let's see, let's start off by listening to what the wave I'm going to be... That's the wave I'm going to be sending in. So I'll pull out of that, put it into low pass, and now where the heck was I? It's this blue, it's the blue wire. Now we'll turn on the sequencer. Let me turn some things to about, oh, you can hear it a little bit now. I'm going to turn everything up to about half. That's the way it sounds. Let me pump it through here. Going to change the frequency. Add some more Q. You can hear it there. If I go even lower, let me turn this all the way up, which is the slope. I'm going to take the slope down. Slope up. I'm going to put the volt per octave in just for a second. I don't know if it's going to do much. Mix all the way on that side. Mix all the way on that side. Actually, what I'm going to do, I'm going to put a different waveform from the same oscillator, but a different waveform into N2. That's the even. Well, I know what I'm doing. I'm not going through a VCA on there. I'm sorry. Let me go through the VCA. Another cable. I need another cable. Put that cable there. Put that cable there. And then I've got to multi-out my trigger. So let me go. The trigger goes over here now. And then I got to get some long cables to take it back to more VCAs. I'm sorry, I should have configured this before, but I didn't, so that's what we get. Actually, I'm going to take this into the... That sounds pretty neat. Take the frequency up. Now we're all the way over on this side, so I want to put the LFO into here and see what that does. Adds a little flutter. Take it way down. That sounds really nice. Let's go to bandpass just for fun. I think you can tell how the slope is making the cue a little longer. Now I'm going to go to out of high pass. That frequency takes everything out. I'm going to go up an octave. Well, I'll tell you what, I like this filter a lot. It's got lots of life, lots of rich, lots of denseness, the Q is not overwhelming, but it's very good. No, this is a really nice sounding unit. I really recommend this. And as you saw, it's a pretty straightforward build. So, a very good one from Random Source and Serge. I highly recommend this. And I hope you enjoyed the video.